Our next speaker is Cedrik Neike. Cedrik has been a member of the managing board at Siemens since 2017. And in October 2020, he also became CEO of Siemens Digital Industries and assumed responsibility for Siemens IoT business, cybersecurity, and IT.
Achim, ladies and gentlemen, it's a pleasure and honor to be a keynote speaker at this great event today. It's a virtual appearance, of course, but pretty much standard practice these days. But at least I'm with you in spirit and interest. And who knows, in the not too distant future, everything could be quite different. My speech and panel discussion will be recorded, processed, and trained with AI. And a perfect life-size hologram copy of me will then hold my speech and answer all of your questions, wherever you may be. You say not possible? Well, just ask William Shatner, who my generation knows better as Captain Kirk. He is convinced it will happen, as he demonstrated on his 90th birthday by partnering with Storyfile. The Storyfile company promises just that, an AI clone that will enable you to talk to Captain Kirk after his death. Granted, a somewhat scary thought, but perhaps not for the Star Trek star personally. I think I'm a bit skeptical, but then not everybody has such a huge amount of data available for AI processing and training as Captain Kirk. So you see what's becoming possible with big data and AI. And what about industry, here and now? Today, I'd like to take you beyond this hype, right into the real world of AI applications. Automation, digitalization, and big data are currently experiencing a boost. Why is that? COVID-19 has overrun the world like a tsunami and has fundamentally changed our lives. The activities of business and entire industries plunged virtually overnight. Factories shut down, people had to quickly shift to home offices, supply chains were disrupted, our everyday lives were radically altered. But we've clearly seen one thing in the COVID crisis. Companies that had already digitized and automated many processes have weathered the crisis much better. They were able to flexibly adapt their production to changing demand. Many industries, like pharmaceuticals or hygiene products, had to quickly ramp up output. Others, like automotive or aerospace industries, had to swiftly cut back or even shut down production. And this happened at Siemens as well. At the start of the first lockdown, some of our factories couldn't even reach 75% of their productivity. Yet, within a few weeks, nearly all of them had recovered to full capacity. Two things helped us. First, working closely with our customers and partners because it's obvious no one can master this challenge alone. Second, digitalization and automation, combined with cutting-edge technologies. This combination helped us to use data even more intensively and sustainably. Because there's one thing for sure, independently of COVID, our resources are finite, but the data is infinite. Our job is to use it intelligently. Only then can we achieve the flexibility we need to master all of these new challenges that lie ahead of us. This is where artificial intelligence comes into play, and its capability to collect and analyze vast amount of data and equip machines and people with digital capabilities. AI can now act as an unprecedented amplifier of intelligence and productivity. AI has a huge economic potential, possibly contributing $5 trillion to global value add by 2025. And this was figured out before the pandemic. In principle, the technology of artificial intelligence isn't that very new at all. Siemens has been doing research in this field for over 30 years, with AI hubs spanning the globe from Princeton to China and back to Munich. And we partner closely with neighboring universities. Taking a look at our patent position, we ranked number 11 worldwide and the number 1 in Europe. On the AI side, we're number 1 in engineering applications and number 1 in healthcare. And even way back in the 1990s, we were already installing neural networks in steel mills. Since then, the technological progress has expanded this potential to astonishing dimensions, as you know. Computing power and speed in data transmission has soared. AI chips with increasing processing speed boost machine learning, and we at Siemens help to build them with our Mentor software. With our Mentor tools, we are providing world-leading physical verification tools needed for all chips, also for the AI chips. Mentor is using AI for this verification. Furthermore, with that tool set, we will provide compiler to transfer data science framework into AI chip designs. We're talking about high-performance algorithms that are already available. The growing digitalization of entire work processes is vastly increasing data assets. And all of this data can now be used as input for AI application. Today, we use this technology in various applications areas across industries as part of our next step to what we call Industry 4.x. Let me give you some examples to make it real. No worries, I won't take a deep dive into all of the field. Let's start with autonomous systems. As part of the autonomous systems, robots solve handling tasks independently. Equipped with smart object recognition, they can process unfamiliar workpieces. They learn without any time-consuming training. And they process data directly in their neural networks. This is the intelligence at the field level. What else is there? AI can also help in product design. We offer a software that combines design with machine learning. The system predicts and recommends the next processing step based on the user's routines. The tool continuously adapts to the users and support them in using the software more efficiently. So imagine you would actually design a product and the AI would tell you, well, this sort of part of material could be much, much more sort of sustainable, and you would use it. You probably know this device very well. It's a classical printed circuit board, in short PCB. But this time it was controlled in an entirely new way. The PCB production uses edge computing and AI. Circuit boards accommodate function-related bus connectors with various connecting pins. In a non-integrated test, the solder points of these connection pins are X-rayed and checked for correct functioning. At one point, we ask ourselves, should we buy another X-ray machine because we have more PCBs? It costs around $500,000. But we found an alternative solution using artificial intelligence. Data from the sensors is transmitted to a cloud, which consists of a controller and an edge device. Experts train an algorithm based on AI and on the process parameters. The algorithm learns how the process data reflects the quality of the soldering points and then creates a model that runs on the edge of the application in the plant. The model can predict whether or not the solder points of these PCBs are free of fault. In short, whether the end-of-line test is necessary or not. Thanks to this closed-loop analytics here, data can immediately be factored into that production. And key production data stays within the production critical levels. No interaction with the clouds are necessary from this point on. In the future, we'll be expanding our portfolio so we can enable seamless transition from machine learning workflows into factories. In data acquisition, data pre-processing, AI training, and model deployment and operation inside a manufacturing plant. Our goal is to continuously improve the algorithms and retrain machine models to further increase the yield. Overall, we're working to consistently shape and drive the development of use of AI across all industries and infrastructures. Let's look at this use case in a critical infrastructure, such as data centers. All of us are using a lot of data centers even for this conference. The question here is, how can we deal with the massive heat generated by the servers? Using machine learning technologies, we can substantially reduce the demand for cooling energy. We have a great partnership with Vigilant here. And the result of the work, we can reduce cooling by 40%, and therefore also the energy bill. AI-based technologies dynamically addresses the complex of mission-critical white space cooling. Let me give you another example. Imagining you're riding in a comfortable self-driving car, returning home after a long day and enjoying the view. Suddenly another car heads towards you and is about to cause an accident. What if your car quickly and smoothly maneuvers and keeps you and the other driver safe? That's exactly what AI is all about. It makes your autonomous car safe by being trained on billions of miles in scenarios combination and can make sure that no one is harmed. How AI helps design engineers discover all possible dangerous situations and train the software to handle them properly. All of these examples show you that AI will help us use the vast amount of data generated by digitalization more intelligently. AI is the brain of the digitalization. It is the organ that enables us to learn so we can react faster and more flexibly to new challenges. Let me give you an example we have in the industrial AI space at the moment. Normal AIs can differentiate between a cat and a dog. The problem is when a mouse comes along, the AI will call it a dog or a cat. which is okay when you look at your personal photos and you want to make a differentiation. It's not okay when you're in industrial production. Because if in industrial production you make a mistake, you can create millions of defects, you can create harmful environments, you really create an issue. Furthermore, we must make certain that AI solutions are trustworthy, robust, and reliable, and especially secure. These qualities are also particularly relevant for industrial AI. Obviously, this remarkable new industrial world can't and won't be created overnight. Every industry, independent on their size, of their type, need to understand on how to integrate this in a complex environment. And one solution can be actually consulting. Get help so that people help you redesign your processes. And it's especially important that we shouldn't work behind closed doors in making such far-reaching changes. We need to work together to overcome major challenges for industrial customers. Challenges like their lack of quality, real-world data, the lack of robust industrial applications, or the shortage of AI capacity and talents. For me, working together means the entire industrial ecosystems, automation players, IT companies, startups, customers, as well as industrial associations such as Bitkom, academic research, and political institutions need to work together. Whether pairing domain know-how with AI expertise or bringing academic research to the shop floor, succeeding in AI is a team effort, such as the partnership we have with Vigilant, which I just mentioned. Companies of all sizes and all industries need to cooperate at the AI level as partners. Small, medium-sized companies must be part of this ecosystem as well, since they are often highly innovative. Only then will we be able to benefit from this fantastic opportunity offered by artificial intelligence. Ladies and gentlemen, many of the development in the field of AI seems impressive at first. Ultimately, however, they are kid stuff compared to what lies ahead of us. There are plenty of untapped potential in AI. Let's leverage this potential together for the benefits of both economies and societies. Because technologies must do both, contribute to the economic success of companies, but also improve the quality of life for people, for all of us. After all, artificial intelligence will not replace humans. It can make our work more productive, safer, more interesting, and less vulnerable to errors. And providing more time for truly creative work by automating simple tasks. But it will always remain a supplementary function in a fruitful collaboration between humans and machines. So, let's tap the potential of AI by increasing flexibility through AIs for all challenges that lies ahead of us. Driving innovation and implementation, building trust in AI's benefit. Raising awareness of opportunities through AI. This way we can shape technological and social progress anywhere in the world together. With that, I wish you all a successful conference with lively and productive discussions. Thank you.